So how do we assess this? So at this point, we've kind of got a physiological rationale, but we haven't dealt with how to assess this. So again, we're going to go back to the work from the key instigators within this, which is the work from Andy Jones, Annie Van Hattelo, and Mark Burnley, along with Dave Paul. So we have to think about a number of things. The first thing is the number of trials. Remember, you've got to do repeat trials. Clearly, the number of trials that you have is going to affect the fidelity of that curve. If you've only got 2 trials, you cannot get a hyperbolic. You'd only get a linear relationship. So you need really at least 3, but ideally the true minimum is 4 trials. Ideally up to about 7 trials are needed. The next thing you've got to think about is, and I'm going to jump this one here to come to this one to explain why, all the trials need to be in the severe exercise domain. Because remember that you're demarcating the boundary between heavy and severe, you're demarcating that exhaustion, the depletion of the W prime. W prime will not be depleted in the heavy domain. Remember that in all of those conditions on that previous graph we saw, the area for the W prime is identical. So they all need to be in the heavy domain, in the severe domain. So these are really high intensity bouts of exercise, which then connects to the duration of the trials. Well, what we know is this: the minimum duration should be about 2 minutes. If it's less than 2 minutes, the likelihood is you've gone above, really way too far above the intensity that we're looking for. One would argue, well, is 2 minutes too short? Well, no. You could. 2 minutes is the equivalent to doing something like an MAOD trial, which is about 120, 130% VO2 max, but no longer than 20 minutes. Why no longer than 20 minutes? Well, actually, if it's longer than 20 minutes, we know that you're stopping for the wrong reasons. You're not stopping due to exhaustion. You're stopping probably due to things like stoicism and boredom. It becomes a psychological battle. So really, you're looking at a range of intensities from about 120 down to about 90% of VO2 max. Quite a fine range, but we know that those would put you in the severe exercise domains. If you're doing it on a bike, we know that the cadence has a big effect. If it's too slow, then we know that fatigue, despite the fact that you are in the severe domain, fatigue is going to cause you to stop. If it's too high, then actually it's a CNS-based fatigue. You get kind of a neural response. So the cadence actually has to be matched to the cadence at which somebody will have done a VO2 max trial. So you can't allow the participant to alter the cadence during the test itself. So there's quite a lot of things to think about here in terms of the setting up of a critical power trial. And this is again from Andy Jones, and it's really important. Power time curves were constructed using data obtained from 4 or more independent high-intensity constant power exercise bouts, for which the tolerable duration, they've gone here for about 2 to 15 minutes. I think you can go up to maybe 20 minutes. But 2 to 15 minutes really kind of puts you in a really nice boundary for that 120 to about 90% VO2 max. Higher power outputs that were predicted to induce exhaustion in less than 2 minutes were expressly avoided because of concerns that constraints related to mechanical power generation may become apparent. Similarly, far lower power outputs where the subject would not fatigue until 15 to 20 minutes and which would likely entail a greater motivational component were not used to determine critical power in W prime. So we've got this window. They've got to be in the severe domain. And you can just see here some really nice data, which is, well, actually, how long should I leave between my trials? Remember that you've got to do multiple trials. So what they've done here, what the group have done here, is they've said, okay, we'll look at what happens if we have 24 hours between each trial, which is protocol A, or if we have 3 hours between trials, which is B, or we have 30 minutes between trials, which is protocol C. And what they've got is, and they've done quite a low intensity trial. I think this is too low personally. And these are time to exhaustion, 80%, 100%, and 105% of the VO2 max. So protocol A, so if we look at protocol A to B to C, there isn't an inordinate difference at 80%. But now look at what starts to happen. This is prior. Now look at what happens to post. Look at the differences here. 12.5, 13.2, 11.5. So there are quite significant effects going on. You can see that actually, if I have 30 minutes between my trials, the net result is I'm actually not achieving the same amount of work in terms of the blood lactate response, certainly, than I am when I am doing at least my 3 hours or 24 hours between trials. And that really tells us that we're stopping for the wrong reasons. That we've either not had full glycolytic recuperation across these trials, and these are all done in randomized order in this study, or that they're terminated for the wrong reason. If we compare the 3 hours to the 24 hours, there isn't an inordinate difference between these two, where actually it does feel quite significantly different to what's happening at 3 hours. So we would really generally recommend no less than 3 hours between trials, and ideally 24 hours between each trial, because you want the participant to be as fresh as possible to go to volitional exhaustion. And so here we've got kind of an example in terms of the times. So how long did they go for? And it just reinforces what you saw with the lactate response. So here is the 24 hours. So not a massive difference between the two, but they are certainly going for less time at the 3 hours compared to the 24 hours, but a very big difference to when we go for 3 hours across trials. So one would argue actually that we'd probably be certainly better off doing it the 24 hours between trials. Now that really does have issues in terms of the practicalities of doing this that one needs to take into account, but it's probably the best way to achieve this.